So we are going to see about association rules now. So as we know, association rule learning is a rule-based machine learning method. So when we go for association rules, we will find all set of items that have support greater than the minimum support, and then using the large item sets to generate the desired rules that have confidence greater than the minimum confidence. So when we call a particular rule as a valid association rule is that whenever a particular rule satisfies the minimum support as well as the minimum confidence. So we are just going to see an example by using the a priori association rule algorithm. So you have so many association algorithms like a priori, FP growth and LCOT algorithms. So now we are going to see about the a priori algorithm. We are going to see an example with a priori algorithm. So just look at this example. So in this I'm having a transactional database which has 5 transactions. So each transaction has a transaction ID, right? T1, T2, T3 and so on. So each transaction ID has a list of items associated with it. So you have 5 transactions and each and every 5 transaction has a list of items associated with it. So here if you see, they have given a minimum support as 60% and minimum confidence as 80%. We need to find out the frequent item set and you need to generate the rules using the a priori algorithm. Okay, so the first step is I'm just taking the minimum support. So here the minimum support is given as 60%. When it is given in percent, you have to convert it into a numeric value. So what I'm doing is I'm just taking that 60 divide by 100 into the number of transactions in the example. Here you see the number of transactions in this particular example is 5. So I am taking it as 5. So when I cancel it, I am getting 3. So the minimum support is 3. Okay, whichever element is having the support count of 3 and greater than that can be included. Other elements will be discarded. So when you see, first step is I have converted my percentage into a numeric value and I have found out my minimum support. And the next one is I'm just going to generate the candidate 1 item set. So I'm going to this transaction table and I'm seeing what are all the elements are there in this transaction table. I'm just listing down all the elements that are there in the transaction table. So I have listed all the elements. So here if you see, for example, I have taken M, okay, and I'm seeing M is present in how many transactions. So if you see 1, 2, 3, it is present in 3 transactions. So I am taking the value of 3. So for each and every element, I am just going to find out the in how many number of transactions that particular element occurs. So when you come to this one, when you come to this particular example, here if you see, here the O is repeated twice. So you may have a doubt whether to take O as 1 count or as 2 count. Okay, one main thing you have to note, that is you are just going to see the number of, you are just going to see in how many transaction O occurs. Okay, it is not that how many times O occurs. You are just going to see in how many transactions O is occurring. It is not that how many times O is occurring. So if you see, you have to count this as 1. Okay, you should not count it as 2. You have to count it as 1 because you are seeing in how many transactions O is occurring. Okay, so the value is 3 here. So I have just like that I have taken for all the elements. Okay, so one candidate item sets, all the elements I have taken, and I am now comparing it with my minimum support. So whichever element is not having this minimum support count should be eliminated. So I am eliminating N, D, A, U, C and I because all these elements are having support count which is less than the minimum support count. So I have eliminated all these elements and this is the list of elements that is having the minimum support count. Okay, once this is done, I am moving on with my two candidate item sets. So if you see, I am just going to take the combinations of two item sets. So M with O, M with K, M with E, M with Y. Just like that, I am finding all the combinations of two item sets, and I am finding out the support count of each and everything. So once again, once it is done, I am just going to compare it with my minimum support. Whichever pair is not having this minimum support count, I am just going to eliminate those pairs. Okay, so I have eliminated everything, and my L2 is this one. Okay, and now you see, after this I'm going to generate my candidate 3 item sets. So here if you see, you have OK and OE. So here the first two elements are same. So I am just going to use the concept of self join. So when I do it, it will be OKE. And then here also you see, you have K and K in these two things. K is the first element. Once again, I am going to apply the self join concept, and then I am using KEY. Okay, and then I am whenever you do this, you may have so many other list of item sets. So I am just seeing the support count of these things. So this is 3 and this is 2. So if you see, KEY is not having the minimum support count, so I am eliminating this one. So my final frequent item set is the OKE. Okay, this is my final frequent item set that is having the minimum support count. Okay, once this is done, this is first half of the problem is over. With minimum support, I have found out my frequent item set. Once this is done, I need to generate the association rules. That generation of association rules must be done with the help of the minimum confidence value that is given. Okay, so just listen here. So I'm just going to generate the association rule using the minimum confidence that is given, that is 80%. Okay, whichever is not having the value more than 80% or equal to 80%, those rules will be eliminated. Whichever is having more than the 80% will be accepted. So if you see, the frequent item which we have generated is OKE. Once the frequent item is generated, I am going to write all possible subsets of this particular item set. So when I write it, you will be having these many sets. You have some 8 sets. So in this, I am just going to eliminate the empty set as well as this full set. Okay, I am just eliminating it. I am just going to consider these 6 sets for my rule generation. Okay, so the first rule I am going to generate with my OK. Okay, my rule 1 is O and K implies E. If someone is going to get O and K, that implies he may get E also. Okay, that is what this rule implies. So I'm just going to find the confidence. You know the confidence formula. It is support of A union B divided by support of A. So here in this case, this will be your A and this will be your B. So support of OKE divided by support of OK. So just take the count of these two. So that is 3 divided by 3, that is equal to 1, that is 100%. So now I am comparing this with my minimum confidence value, that is 80. This is more than the minimum confidence, so this rule is accepted. Okay, I am moving on with the next one, that is rule 2. I am taking KE. Okay, K and E implies O. So same way, support of KEO divided by support of KE. So take the count, it is 0.75, which is less than the minimum confidence 80%. So I am eliminating this rule. Same way, I am moving on with OE. Okay, it is also giving me 100%. So this rule is accepted. I am moving on with O. Okay, if someone is going to purchase O, that implies they may go with K and E. So support of OKE divided by support of O. Okay, this will be your A and this will be your B. So 3 divided by 3, that is 1, that is 100%. So this rule is also accepted. I am moving on with my next one, that is K. K implies O and E. So here you see, it is 0.6, that is 60%. So this rule is eliminated because it is having less than 80%. So this rule will be eliminated. I am moving on with my last rule, that is with E. E implies O and K. Support of K, O, E divided by support of E, that is 3 by 4, that is 0.75, 75%, which is less than 80%, so it is eliminated. So if you see here, rule 1, rule 3 and rule 4 are accepted, and rest of the rules are eliminated because it is not having the minimum confidence value. So my final rule that is generated, this 3 rules are that satisfies both the confidence as well as the support. Okay, so I'm calling these 3 rules as the valid association rule. This is how your a priori algorithm works. Okay, just see to it. If you like it, just like the video and just comment on it. Thank you.